High in the Bolivian Andes, at an altitude where even breathing is a struggle, lies a megalithic ruin assembled with engineering precision. Modern tools cannot match perfect H-shaped blocks cut from stone, harder than steel, locked together with sub-millimeter accuracy. No tool marks, no primitive chisels have ever been discovered, and not a single record exists of how it was built. Officially, the story stops at 1500 years ago. The evidence, however, hints at something far older and far stranger. If the limits of possibility were shattered here, the real question is who or what designed Puma Punku, and why does history refuse to answer? At nearly 13,000 feet above sea level, the Bolivian Altiplano is a world of thin air and biting cold. Sunlight cuts through the sky with a sharpness that leaves little room for shelter or comfort. The ground stretches flat for miles, broken only by the distant shimmer of Lake Titicaca and the low, angular ruins that seem to rise from the earth itself. This is not a place that welcomes visitors. Even today, the journey here is a test of endurance. Roads twist through mountain passes, and the wind never lets up. For early explorers, the isolation was even more severe. In the early 1900s, an Austrian-born engineer named Arthur Posnanski arrived on this remote plateau, notebook in hand, determined to make sense of the silent stones scattered across the landscape. He found more than weathered walls. Massive blocks, some weighing over 100 tons, lay half buried in the ground, their edges still crisp against the relentless wind. The sheer scale of the site, combined with the altitude, raised questions that no easy answer could satisfy. How could anyone have built here, where crops struggle and every breath feels like a labor? Posnanski spent decades documenting every angle, every alignment, convinced that these ruins held secrets older than any local legend. His sketches show blocks precisely carved and fitted, untouched by the erosion that wore down lesser stones. He wrote of solstice sunrises casting shadows along exact lines, and of an ancient people who seemed to have mastered both engineering and the unforgiving highland environment. Yet for all his careful observation, the logistics of construction remained a mystery. No roads, no ramps, no traces of the tools that could have shaped stone of this hardness. The plateau itself seemed to conspire against the possibility of human achievement on this scale. Even now, the wind sweeps through Puma Punku, carrying dust across the ruins and erasing footprints within minutes. The silence is broken only by the call of distant birds and the steady breath of the mountains. It is a place where the environment itself becomes part of the puzzle, where the sheer act of building is as astonishing as the stones themselves. In 1969, a rainstorm swept across the Altiplano, soaking the earth around Puma Punku. As the ground softened, archaeologist Carlos Ponce Sanguinez led a team that began to unearth what lay beneath the surface. Instead of random stone scatter, they found rows of H-shaped and T-shaped blocks, each one nearly identical, as if produced from a single industrial plan. These were not just massive stones, they were modules designed to fit together with a precision that rivals modern factory standards. Measurements taken on site reveal that the joints between blocks are so tight that even a thin razor blade cannot slip between them. Some seams measure less than a millimeter across, a tolerance level that pushes the limits of what is possible, even with today's best CNC machines. The repetition is unmistakable. Dozens of H-blocks, each carved to the same dimensions, interlock like pieces of a giant stone puzzle. Their faces are perfectly flat, their angles sharp, and their internal channels align across multiple blocks, forming continuous grooves and sockets. This is not the work of improvisation or trial and error. The builders followed a standardized blueprint that allowed for mass production and rapid assembly. Rows of blocks, once hidden by centuries of soil, reveal an intentional order beneath the apparent chaos of the ruins above. Some blocks include seismic interlocks, protrusions, and recesses that lock together and protect the structure from earthquakes. The modular system allowed for repairs and replacements without dismantling the entire platform. Each piece, whether H-shaped or T-shaped, was made to slot into place, forming a stable, unified whole. The logic of the design suggests not just skill, but an understanding of engineering principles that would not become common knowledge for thousands of years. The full scale of this system only became clear after Sangiovese excavations. What looked like random debris from above was in fact the remains of a carefully planned and executed construction method. The question that lingers is not just how these stones were shaped, but how such a sophisticated system of modular architecture appeared in a place so remote and at a time when the rest of the world was still building in mud and timber. Diorite is no ordinary stone. On the Mohs scale of mineral hardness, it ranks at level 7, harder than steel files and harder than any copper or bronze tool ever found in the Andes. This single property sets a barrier that most ancient builders would never attempt to cross. In modern workshops, machinists use diamond-tipped blades and water-cooled saws just to score its surface. Even so, the process is slow, the blades wear down quickly, and the risk of fracturing the stone is constant. Attempts to replicate Puma Punku cuts with steel chisels or rotary tools end in failure. The edges crumble, the surfaces chip, and precision is lost long before the tool reaches the required depth. Engineers like Chris Dunn have brought diorite samples into their labs, determined to match the crisp lines and flawless angles found in the Altiplano. High-speed diamond drills leave spiral marks and hairline fractures, scars that are completely absent from the ancient blocks. Even with computer-guided CNC machines, maintaining sub-millimeter tolerances across a 1-meter wide face is a challenge. The stone resists every effort, dulling blades and blunting bits in minutes. Geologists confirm that the diorite at Puma Punku is densely packed, with interlocking crystals that make it especially tough. When struck, it does not flake or split easily, it shatters unpredictably, making clean cuts nearly impossible without advanced equipment. Yet the H-blocks show faces as flat as glass, and angles that meet at perfect right angles. No evidence of abrasive residue, no pitting, no uneven surfaces, only the smooth machine-like finish that continues to puzzle experts. The raw material alone raises the stakes. What kind of technology could have shaped stone this hard, this precisely, in a world where even iron was unknown? Rows of H-blocks and lintels at Puma Punku reveal a detail that baffles even seasoned machinists. Perfectly round holes drilled straight through diorite and andesite, some just 6 millimeters wide, all without a trace of spiral scoring. Industrial 3-dimensional scans show these bores are not only concentric, but they maintain a consistent diameter and depth, with sub-millimeter tolerances across blocks weighing several tons. The holes appear in repeating patterns, spaced with mathematical regularity along grooves and inside modular channels. Many are blind holes, their ends squared off with crisp, machine-like precision. Others run through the full thickness of the stone, emerging at exactly the same angle and position on the opposite face. Attempts to reproduce this level of accuracy with ancient tools, stone hammers, copper tubes, and sand abrasives fall short. Experimental drills leave irregular walls, residue, and obvious chipping. Modern diamond core bits can approach the precision, but they always leave behind spiral grooves and glossy tool marks. At Puma Punku, the whole interiors are smooth, unblemished, and free from the telltale scars of rotary abrasion. A machinist examining the scans shakes his head in disbelief. He says, "Even with a CNC you would expect some chatter or drift, especially over that distance." Yet the holes at Puma Punku hold their axis perfectly, lining up across multiple blocks as if guided by a rigid template. The geometry is so consistent that engineers suspect a standardized grid system was used, with holes and grooves matching across dozens of stones. No ancient workshop debris, no broken drill bits, no evidence of the tools themselves has ever been found at the site. What remains is a silent record of small-scale perfection, embedded in rock harder than steel, achieved with a finesse that continues to defy explanation. Moving a 130-ton block of stone is not a theoretical problem at Puma Punku. It is a physical reality, written in red sandstone and andesite. The largest slabs, some weighing as much as 150 tons, have been traced to quarries at least 10 miles away on the far side of Lake Titicaca. The route from the Copacabana Peninsula to the Altiplano crosses open water, steep inclines, and stretches of uneven ground that would challenge even modern heavy equipment. Archaeologists have tried to model how such massive stones could be transported across this landscape. The most common proposal involves totora reed rafts built using traditional techniques still practiced by the Aymara people. In the 1970s, teams constructed rafts up to 15 meters long, then attempted to float blocks weighing multiple tons across short stretches of the lake. The results were sobering. Rafts carrying even 20 tons struggled to stay afloat, their hulls dipping dangerously low as water sloshed over the sides. Stability vanished in the slightest chop. When modern engineers scaled up the experiment, loading a 40-ton concrete block, the raft flexed and threatened to break apart before it reached the far shore. No team has ever succeeded in moving anything close to a 130-ton megalith by water, no matter the technique. On land, the challenges multiply. Wooden sledges and teams of hundreds can shift 5-ton blocks over wet sand, but the friction and weight of a Puma Punku slab quickly overwhelm any ancient technique. Steep slopes leading up from the lakeshore make the final ascent nearly impossible without advanced machinery. There are no traces of the massive ramps or causeways that such an operation would require, and no evidence of the tools or infrastructure needed to move stones of this scale. The logistics gap remains, an unanswered question sitting at the heart of the ruins. Archaeologists have long attributed Puma Punku to the Tiwanaku civilization, placing its construction between 500 AD and 600 AD. This dating relies on radiocarbon samples taken from organic material buried within the mound fill and on pottery fragments found in the upper layers of the site. In academic circles, the Tiwanaku builders are credited with shaping, transporting, and assembling these megalithic blocks using copper chisels, stone hammers, and simple ramps. The official narrative holds that a thriving highland society, skilled in agriculture and communal labor, organized the construction as a political and religious center. Yet when the physical evidence is examined in detail, the picture grows less certain. Excavations have failed to produce a single copper or bronze tool capable of cutting diorite or andesite, the hardest stones used in the site's construction. Archaeological digs have turned up bone awls, stone pounders, and a handful of bronze ornaments, but nothing that matches the scale or precision demanded by the blocks. No tool marks, no chisel scars, no abrasion patterns appear on the surfaces. The absence extends to the workshops themselves. There are no unfinished prototypes, no discarded fragments, no debris fields where failed attempts might have accumulated. Radiocarbon labs have dated the site's fill material and some of the overlying structures, but the megalithic blocks themselves remain undated. The stratigraphy suggests 3 major building phases, but the earliest layers offer no clues about the true age or origin of the largest stones. When compared to other Andean sites, Puma Punku stands alone, its modular system and sub-millimeter tolerances appearing fully formed, without any evolutionary stages or earlier attempts. The mainstream explanation, tested against the physical facts, leaves fundamental questions unanswered. The gap between the official timeline and the engineering evidence opens the door to deeper mysteries. 3 explanations now compete for the origins of Puma Punku, each raising questions that reach far beyond the Bolivian highlands. The first, championed by Arthur Poznański and others, argues for a lost civilization with knowledge and technology that vanished long before the rise of Tiwanaku. According to this view, the site's modular H-blocks, sub-millimeter joints, and standardized blueprints point to an industrial-scale operation, possibly dating back 10,000 to 15,000 years. The catastrophic scattering of blocks across the site is read not as the slow work of time, but as evidence of a sudden, violent event. Perhaps the same flood described in Andean legends and echoed in ancient texts from Mesopotamia to the Mediterranean. A second theory looks for answers in the stones themselves. The absence of tool marks on diorite and andesite has led some to propose unconventional techniques, acoustic levitation, chemical softening, or the use of unknown vibrational tools. Aymara oral histories speak of Viracocha and the first people, beings who could move mountains with sound or soften rock with sacred plants. While no physical evidence confirms these methods, the perfect drill holes and glass-like finishes on Puma Punku's hardest stones continue to resist explanation by any known ancient technology. A third hypothesis suggests knowledge transfer from an advanced source, whether a forgotten culture, survivors of a global cataclysm, or something even more mysterious. The sudden appearance of fully developed engineering, with no evolutionary steps or failed prototypes, mirrors what researchers find at other megalithic sites around the world. At Baalbek in Lebanon, trilithon stones weighing over 800 tons are set with a precision that rivals Puma Punku's H-blocks. In Egypt, obelisks and granite boxes show similar tolerances. Patterns repeat at Sacsayhuaman, Easter Island, and most strikingly at Göbekli Tepe, where T-shaped pillars carved 12,000 years ago suggest a global network of ancient builders working from a shared template. The debate remains unresolved. Radiocarbon dates and stratigraphy support the Tiwanaku timeline, but geological evidence and indigenous flood myths hint at a much deeper past. No matter which theory one favors, the site stands as a challenge to conventional history, a silent witness to skills and events that official narratives struggle to explain. The same questions that drove Poznański to map the solstice lines now echo in labs and lecture halls around the world. Who built Puma Punku? How and why? The answers may lie not just in Bolivia, but in a network of ancient sites that span continents and eras, each guarding its own share of the mystery. Today, the stones of Puma Punku stand as a silent challenge to our understanding of human history. Their precision, unduplicated by modern technology, forces us to question what we accept as possible. As new data emerges, the story of these ruins grows more urgent. The boundaries of human achievement may be far older and stranger than we dare imagine. What do you think we are missing?